Okay, so this is week 2, Thursday, 2024, semester 2 for Math 6. And their topic is going to be on ratios. So looking at this first part right here, this is an introduction to unit of rates. See, these snails are moving very slowly. Here's our speed. Snail A is 5 inches in 10 minutes. Snail B is 3 inches in 20 minutes. Snail C is 1 inch in 15 minutes. And snail D is 6 inches in 30 minutes. You're going to use the information here for the table that you're going to be working on over here, I believe. So here we go. All right. So this question says, use a ratio table from the snail crawl. Graph each snail's progress on the same coordinate. Use a different color to represent each snail. So you have your color pencils, yes. Don't write the coordinates of the points. Just put dots to represent each point. So do not write the coordinates, so no x, y values. And then know that you may not be able to graph all points. Okay, so first thing you're going to know is what is the x-axis going to represent? What is the y-axis going to represent, right? Remember, x-axis is left to right. Y-axis is up and down. Do you see that? So here is the y-axis. Y-axis is going by 5, 10, 15, 20. And what is it representing? What does that say? So this is time in minutes, okay? What about the x-axis, which is going left to right? In inches, okay? So this x is distance in inches, okay? All right, so let's take a look at snail A. So let's grab a color pencil. I'm gonna do blue. Snail A is 5 inch, 10 minutes. So if you have to write that, so this is snail A. Remember x and y. X is distance. Distance is 5, so we can put 5 here. Minutes is 10. That's y, so put that right there. So I'm going to go down here. I'm going to go 5 to the right for distance, right there, and then 10. So right there. Okay, so that's your first point. She said, don't write the corner of the point, just put a dot representing each point. Does she want us a label either? So I'll just put A maybe. Here's A. Okay? Does that make sense? Okay, so then let's go ahead and find a different color. Let's do purple. I'll do purple, you do whatever. So this is snail B. Snail B is going to be 3 inch in 20 minutes. Okay, so 3 inch in 20 minutes. So here is 3, 1, 2, 3. 20 minutes is gonna go all the way up here. So that's snail B. Good? Okay. So pick a different color. I'm gonna do green, which is gonna be snail C. Snail C is going to be 1 inch in 15 minutes. So 1 inch in 15 minutes. Do you see how distance is the x value and minutes or time is the y value? You cannot swap them back and forth, okay? Make sure they're consistent. So 1 inch, 15 minutes. So here is 1, 15 is gonna be right here. That is C. Are we good with that? Okay, pick a different color. I'm gonna do purple. So then D is 6 inch, 30 minutes. Yeah, this grid is not very useful because there's way too many numbers and distance, and snails do not move very far. So 6:30, and that's why I gave you the ruler, because sometimes it's hard to see which line you're on. You know what I mean? Right? So use a ruler to line it up. So this will be D. I think that's all she wanted you to do. Use different color represent each snail. Just represent, you may not. Okay, great. So in this case, that's it. All right, so that's all you have to do for that one. That's it. All right, let's go on to the next one. Next one is on the back. So pay attention for question number 2. So question number 2 says, when Americans travel to another country, they often exchange American dollars for money in that country's currency. When my son lived in Spain, the exchange rate was $1 US is equal to 0.8 euros. So in this case, Grayson, which one is actually worth more? Which one's worth more? Which one's more expensive? No, euro, because $1 here only gives you 80 cents there. Does that make sense? $1 US equals 80 cents. So $1 in America give you 80 cents euro. Okay? It just says like $1 here will equal $1.25 in Canada. Okay? So then no, okay, think of it this way. If $1 US, let's say for example, equals let's say $10 in Mexico, right? So you look at it and you're like, okay, well that you get a lot of more money in Mexico. It's 10 times more, right? For $1, you can probably get a hamburger in America, right? But what if in Mexico, a hamburger costs $20? Does it matter that you have $20 then? Because it's twice as much, right? So then it'll be cheaper to live in the US. So just because it gives you a ratio doesn't mean that you're more wealthier in another country. You gotta look at how much things cost. And it doesn't make any sense if like a hamburger costs $1,000, and you just walk around the country with a bunch of money just everywhere, right? That doesn't make any sense, right? Fill in the table below. So let's take a look at the table. So here it says US is 1, that's 0.8. If US is 2, remember this is just 0.8 times 2, right? Next one, 3 times 0.8, which you got 2.4. That's good. Next one is 5 times 0.8. 5 times 0.8 is 4.0. Do you see that? $5 US gives you $4 in European money. Here, it's just going to be 0.8 because the exchange is 0.8, right? Times 7. So 7 times 8 is? No, it's 56, but she put 6.4? That should be 0.56 or 5.6. So I don't know. You might want to ask her about that. Okay. Would you ask her about that? It's 4.0 for 5 because 0.8 times 5 is 4.0. But if it's, oh, you know what? You did this wrong. So hold on a second. So what it's asking you is 0.8 times what number equals 6.4? What do you think that number is going to be? Times 8, right? So this is not 7, that's 8. Do you see that? Because of that 7, do you see how you're skipping from 5, you're skipping 6, you're skipping 8? But if you did have a table here, and let's say it was 6, do you see how 5, then it's 6? 6 times 0.8 is going to give me 4.8. Do you see that? But that's missing, okay? And then if you put 7, 7 times 0.8 is going to give me 5.6. But that's the part that's missing. But this technically belongs right in here. Do you see that? Okay, but she did that to deliberately kind of confuse you a little bit. So you just need to be smarter than what the question's asking you. Okay? Okay, so then let's move on to the next part. All right, then 2B, draw a scatter plot of the relationship for each situation. Okay, so this is like the grid, right? So remember, when you're doing this, you definitely need to label what your x is equal to and what your y is equal to. What is your x equal to? Which is right here. US dollars, right? What is your y going to be equal to? Which is right here. Okay, so your y is euros, right? All right, so let's go ahead and label this. First point, this is your first point right here. Okay, US dollar is the first one, but remember, X goes right here, so that's 1. Euro is second, right? So this is X, which is US dollar, right? Y, which is euro, right? Y is 0.8. So 1.8, that's 0.5. Do you see right here is 0.5? Right there? 0.8 is right there. Do you see that? It's kind of a little hard to see. I'm trying to make it as big as I can. Do you see that? Right there, okay? Then let's go on to the next point. Second point is 2, 1.6. Right? Here's 2. There's 1. 1.5 is right here, so 1.6 has to be right there. Okay? Next one. 3, 2.4. So here's 3. There's 1. There's 2. 2.4. This is 2.5. So 2.4 is right there below that. Do you see that? Okay. And then 5 is going to be 4. So 5. Whoops. So at 5, you're going to go to 4. Or no, hold on. That's wrong. Oh, you know what? Hold on a second. I need to screw this up. I moved this. Hold on. I need to move it back a little bit. Here we go. Okay. Okay. There we go. Sort of. It's 5, 4. So this is 5. 4 is right here. And then last one is 8, 6.4. So at 8, 6.4 is right here. Do you see that? If you were to draw a straight line here, which you don't have to, this line represents a linear function because it goes in a straight line, okay? And remember, we use this one for, what do we use it for? Prediction. Like, if I were to use $10, how many euros, like, you can kind of like make a prediction, right? Yeah. Okay, like for example, if I were to say, now I don't have any points in between, but what if I use $6? If I were using a $6 making a prediction, I would say I'd probably get like 5 point something euros, right? Or if I say $7, I will probably get 5.9 euros, maybe 6 euros. Do you see that, Grayson? That's how you make predictions. All right. So that's B. C is the ratio number of dollars to number of euros the same for each entry in the table? It should. And the reason I say it should is because what do you notice that your number of euros going up by? It's just like using 0.8. Do you see that? So if I want $3, I do 3 times 0.8, and that gives me euros, right? If I want $120, like the table doesn't have $120, but if I were using $120, how would I find that? 0.8 is a ratio. You'll time that by 120. Do you see that? Okay. So then how you should respond to this is a ratio of US dollars the same for each entry in the table? You will say, yes, the ratio of US dollar is 1 to 0.08, which is euro. Does that make sense? Okay. So to get the amount in euro, I take 0.8 and then times by the number of dollars. And that's what you do. Whoops. Does that make sense, Grayson? Okay, so then let's move on to the next part. Now on number 3, okay? So for number 3, it says peanuts sell for 75 cents a pound. Emma, that's not yours. Okay, so peanuts are for 75 cents a pound. So this is your ratio, okay? 75 cents equals 1 pound. Do you see that? So we have money and weight of what? Peanuts. Okay, so let's fill in this table. You ready? All right. So when I go ahead and fill in this table, let's say, okay, so 1 equals 0.75. Then 2, it's just going to be 0.75 times what? 2, right? Or you could do 0.75 plus 0.75, right? Which is going to be $1.50. Okay. If it's 4, isn't that just 0.75 times 4, right? Or, it's $1.50 plus another $1.50 because there's 2 of them, right? Which is now $3, right? So to get to $2.25, how are you gonna get the number of pounds of peanuts? You multiply before, but now I'm gonna do the opposite. So to get to this, divide by what? Yep. And then $4.50 divided by 0.75, right? So go ahead and do that. What is that gonna get you? All right, so what do you have? 3 and 6? Okay. And you sure those are correct? Okay. So then over here, we're gonna go ahead and probably graph them. Okay. When we graph them, if you take a look at this, your first one, remember your X value is gonna be the pound of peanuts, and your Y is gonna be the cost, right? So your first one is pound is 1.75, okay? Here's 1.75 is gonna be right there, okay? Second one is 2, 1.5. So here are 2, 1.5 is right there. 4, actually let's go by 3, 2.25. So 3, 2.25 is gonna be right there, okay? 4, comma 3, and it should be like in the straight line. 6, $4.50. And if you look at it, it does give you a straight line, doesn't it? Okay. Now let's go on to the next one. Is the ratio of peanut to the cost of peanut the same for every entry in the table? Well, that's the same answer as the last one. And your answer is yes, the ratio of pounds of peanuts which is going to be 0.75, or I'm sorry, or actually the ratio of pounds of peanuts is 1 to 0.75, which is the cost of each pound, right? So to get to the amount of to get the cost of peanuts, you just take 0.75 and you multiply by how many pounds of peanuts? By the number of pounds of peanuts. Okay. And that is your answer. All right, let's go on to the next one. For number 4, this is our last one. So a taxi cab finds a flat rate of $2, right? plus 75 cents a mile. The charge for 4 miles will be $2 plus 4 times 0.75, right? Because this is how much they're charging for each mile, 0.75. And then you have to multiply that by the 4 miles, right? But they charge you $2, regardless whether you go 1 mile, half a mile, 20 miles, 180 miles, okay? They're still gonna charge you $2. And that makes sense because if I'm like, I just want you to drive me 0.5 miles, then that taxi cab driver is not gonna make a lot of money. You know what I mean? So yeah. So fill in the table below, then graph the relationship using scatter plot. Okay, so if it's gonna be 0 distance, like you're not gonna travel at all, how much is it gonna be? $0, right? I think. Hold on. I would imagine, yeah. If you travel 2 miles, well, actually, I guess it would charge you $2 technically. Because if you just get into the taxi cab and you say, I'm gonna not even go anywhere, they're still gonna charge you $2, okay? If it's 2 miles, then it's $2 plus 0.75 times 2. Do you see that? Okay. So that would be $2 plus $1.50, which is $3.50. You're gonna have to calculate that yourself, so I want to make sure you actually do the work for that, okay? For 4 miles, it's a flat rate of $2 and then 0.75 times 4, which technically is gonna give you 2 plus 3, which is $5, okay? And for 6, it's gonna be $2 plus 0.75 times 6, which is $2 plus $1.50 would be $3, $4.50, which is $6.50. So how many distance will it be for $9.50? Let's work backwards. Minus a $2, right? Which will give you what? $7.50, right? Okay, but then I want to know how many miles. But remember, they charge you 75 cents a mile, so you divide by 0.75. And if you divide it by 0.75, it will tell you how many miles there are. So I just want you to just take a look over here very quickly. Hold on a second, let's see. So if you're gonna go to Desmos, we're gonna go to the calculator. Okay, so remember, it's $9.50, right? But they're gonna charge you a flat fee, right? So $7.50 is what you have after the $2 flat rate. But they're gonna charge you 75 cents a mile. So divided by 0.75, it's gonna give you how many miles? No, right here. 10 miles, right? So then we're gonna go back over here. So that's gonna be 10 miles, okay? Now that you have this chart, you know that this is a linear function. So all the points should go in a straight line. If your point is not going in a straight line, like there's a point that's not on the line, then what does that tell you? That tells you that you probably got that answer incorrect and you go back and check, right? So now let's go ahead and graph it. So cab fare, which was right here. So let's take a look at this then. Remember your X is gonna be distance in miles, right? Your Y is gonna be cab fare in dollars, right? Okay, so first point that you're gonna graph is 0, 2. So 0 distance, they're still gonna charge you $2, right? $2, 2 miles is gonna be $3.50. So 2 miles, $3.50. So far, that's your straight line. 4 miles, $5. So far, still so good, right? Still like a straight line, right? $6, $6.50. 6 miles, $6.50. Still so far so good. And then 10 miles, it's gonna be $9.50. So far so good? Okay. How is this graph the same as a graph for problems 1 to 3? So what do you notice between all of these graphs that we did? So this is problems number 2, right? You see the points right here? What do you have here? Straight line. Here is problem number 3. What do you notice here? Okay, here's problem number 1 that we graphed. What do you notice here? Not a straight line. So this right here is not a linear function, okay? So to go back to this, how is this graph the same as graph for problems 1 to 3? It's not the same. You should say Happy Valentine's Day. You could say that the graph for problem number 4 is the same as problems number 2 and number 3 because the points plotted in the directions of a straight line. Or linear function, right? And that's what you can say. Okay. How is this graph different? These problems had the same ratio or slope, okay? You could say the graph for problem. Am I writing down for you? Okay. Thank you for the prize. Here you go. Here you go. All right, so you can see the graph for problem number 4 is different than number 1 because there is no straight line. The points were scattered. Okay. And there is no correlation. Correlation just means there's a relationship. Like this one has a very strong correlation. Like all the points are in that line, right? Okay. All right, so then last one. Is the ratio distance traveled cab fare the same for each entry? And you can say, yes, the rate for each mile is 0.75. The standard flat rate is $2. So to find the total cost of the cab fare, it will equal to $2, which is a standard rate, plus the first one is gonna be the 0.75 times the number of miles. Okay. And then there you go. This is everything that you need. Okay. And that concludes everything that you need to know for this assignment. All right.